All right, in this video, we will be talking about absolute value functions and the standard form of an absolute value function. So let's start off with the idea of absolute value. So absolute value is the idea that if you have a number line, let's use a different marker. If you have a number line, and here's 0, and you have numbers like 1 and 2 and 3 on here, as well as their opposites, -1, -2, and -3, and so on and so forth, that numbers have an absolute value, meaning their distance from 0. So like 1's absolute value would be, well, 1. It's how far it is from 0. And 2's absolute value would be, well, 2, because it's 2 away from 0. So positive numbers' absolute value are just what they are, right? The absolute value of 3 would also be 3. The absolute value of 1,000,000 would be 1,000,000, because it's 1,000,000 units away from 0. Where the only thing that changes is when we're talking about like negative numbers. So if I have -1, you'll notice that it has the same absolute value as regular 1. It's still just 1 unit away. So the absolute value of -1 is positive 1. And the absolute value of -3 would be -3. You'll notice the absolute value of 2 and -2 is the same, and the absolute value of 3 and -3 are the same. It's really the distance between that number and 0. That's what absolute value is. Absolute value is distance. So, we can make equations using absolute value, and the way we do this is we have a special symbol to indicate it. This is the basic equation, f of x equals the absolute value, that's how we read this, of x. These two lines on the side. You want to make sure they're big, that way they don't look like ones. Anything inside these two brackets, these absolute value brackets, I froze. Anything inside these two absolute value brackets comes out positive. And that's because the absolute value of anything is the distance of something, how far it is away from 0. And distance is always positive. You're never -2 feet away from something, you're always 2 feet away, right? So anything that we put in here for x, any value we plug in, should come out positive. And let me show you what I mean by that. So if I make a chart of numbers I want to plug in, and I plug them into this function, well, if I plug in -2, I get f of -2, and that's going to equal the absolute value of -2. Well, we know the absolute value of -2 is just 2, because it's 2 away from 0. So the absolute value of -2 is 2. So -2 pops out 2. Following this pattern, the absolute value of -1, well, that's going to be positive 1. The absolute value of 0, well, there's 0 distance between 0 and 0, so the distance is 0. The absolute value of 1, if I were to plug 1 in here, well, 1 would just be 1. And 2, you guessed it, would be 2. So it turns out that whenever you plug a number in here, it pops out the same thing as the number you plugged in, except it's positive. So if it started out negative, it becomes positive, and if it's already positive, it stays positive. My old math teacher, Mr. Rhodes, used to say that absolute value is like a washing machine. You put your clean clothes in, your positive numbers. You put your dirty clothes in, your negative numbers. And they all come out clean, positive. Doesn't matter if they were already clean, they just come out clean when they're done too. So, what can we do with this function? What does it look like if we graph it? Well, if I draw a coordinate plane, and I plot these points that I made, you'll get a good idea. So this is a coordinate, -2, 2. Right? We had our x values and our f of x values, so -2, 2 is our first coordinate. Let's plot that. -2 to the left and 2 up. -1, 1 is our other coordinate, so -1, 1. 0, 0, that's the origin. 1, 1 is here, and 2, 2 is here. So you should notice a pattern. We've got this V shape going on, right? Let's make sure that continues. If I plug in -3 here, what's the absolute value of -3? Well, the absolute value of -3 would be 3, because it always comes out positive. So -3 is what we plugged in. That was our x value, right? And out popped positive 3 after it went through the absolute value washing machine. If I plug in regular 3, well, I should still get regular 3, right? So So this value, this pattern continues. I get 4 pops out 4, negative 4 pops out 4, 5 pops out 5, negative 5 pops out 5, and we get this V shape going on forever. So it's like two lines that met in the middle. The point that these two lines meet at is called the vertex. And the vertex is where it all begins. So let's mess around with this function a little bit. You might remember from when doing linear functions that we had this form of an equation for a linear function. F of x equals m x minus h plus k, right? Point slope form. And this functioned as our our vertical shift, moving the graph up and down, and this moved it left and right, a horizontal shift. And of course, this was our slope. Well, absolute value functions are very similar to this. So here's our absolute value function with all of its different variables. And you'll notice it's very similar. We write a instead of m because this isn't really the slope. It's something similar to slope. They're sort of the same. But we give it a different letter so you don't get confused. The h and k are the same though. K was our vertical shift here, moving things up and down, and so k will be our vertical shift here. And h is going to be our horizontal shift. The key is to remember this negative sign in the standard form. There's always going to be a negative there, and that's because if we have a negative h, it's going to move it to the left. And if we have a positive h, it's going to move it to the right. But things work differently when you graph this, so we need that negative there to counterbalance that, and I'll show you what I mean by that in a second. So this is our standard form of an absolute value equation. Standard form. So messing around with these things. Let's see what happens. So f of x equals, let's mess with a first. Let's ignore h and k right now, they're 0, and let's mess with a. So normally in our f of x equals absolute value of x equation, our basic version, right, the one we learned first, there's a 1 in front of here for a. It's hidden, but it's kind of like a slope of 1, right? We don't write it, but it's there. So we saw what happens when this goes on, right? We get something like this, right? And it goes, if you notice from our old graph, the slope of this is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. But also it goes up 1 over 1 on the left side too. So if I change that value in front of there, let's talk about this graph. F of x equals maybe 2 absolute value of x. Notice the 2 is on the outside of the absolute value symbols. If I were to graph that, plug in some points and see what happens. Let's do -2, -1, 0, 1, and 2. If I plug in -2, I get the absolute value of -2, which is 2. And then I times it by 2 in front, 4. If I plug in -1, I get the absolute value of it. Absolute value of -1 is 1. Times it by 2, 2. Absolute value of 0 is 0, and 0 times 2 is 0. Absolute value of 1 is 1, times 2 is 2, and absolute value of 2 is 2, times 2 is 4. So again, you see this pattern of we hit a certain spot and then it starts going back up, right? We have 4, 2, 0, and then it starts heading back up. 2, 4, and you can guess the next pattern. So let's see what this looks like. So if I were to graph this, -2, comma, 1, 2, 3, 4 is our first point here. -1, comma, 2 is next, and then 0, 0. Then it starts heading back up, 1, comma, 2, and 2, comma, 4. Now in green, I'm going to graph what we had last time when we graphed this guy, right? We had 0, 0, so it matched, and then it had 1, 1, 2, 2, and so on. So we've got this one as our basic function, and then when we put a 2 in front of it, it did this. So both sides get steeper the bigger that number is. And you can notice because this one's up 1 over 1, up 1 over 1, but this is up 2 over 1, which makes sense because this number is sort of like the slope, and that's a slope of 2. It does it for both sides, up 2 over 1, up 2 over 1, and so on and so forth. Now what happens if we put a negative number there? So what happens if we have f of x equals, I don't know, let's do negative absolute value of x. Well, if we make a chart to find out what happens. Negative 2, negative 1, 0, 1, and 2. Negative 2 plugged in here gets us positive 2 because absolute value of negative 2 is positive 2. Then we negate it, so we get negative 2. If we plug in negative 1, the washing machine, the absolute value, makes it positive 1. And then the negative on the outside makes it negative again. So it's like we cleaned our laundry, and then this negative outside makes it dirty again. Plug in 0, well, absolute value of 0 is 0, and then we negate it, and, well, negative 0 is just 0. 1 we plug in, absolute value of 1 is 1, our laundry was already clean, and then we negate it, so it becomes negative. If we plug in 2, well, 2 is already clean, so it's just 2, and then we multiply by a negative, and we get negative 2. So now when we graph it, this is what happens. We get negative 2 comma negative 2, negative 1 comma negative 1, 0, 0, 1 negative 1, and 2 negative 2. And if you notice, if we plug in negative 3 here, we get positive 3 negated. It's going to just keep on going like this. So now that negative is the same graph as we had before, this guy. Remember the green one we started with? It's the same one that we had before, except it's flipped upside down. They both have the same slope. They're both up 1 over 1. Except this one is down 1 over 1. And that's because there's a negative sign in front of there. So the negative just means it opens downwards. And if there's no negative in front of there, it opens upwards. The bigger the negative number, the steeper these become. Steeper these become. They get steeper. And the smaller the negative number, the flatter it becomes. Let's mess with some other variables. So we already messed with a, and we know that a kind of functions as a slope. It tells us how steep these two lines are. A bigger a will mean that it's steeper. So steeper than this would be like this, right? And a negative a means it opens downwards. The closer a is to 0, the smaller it is, the closer it is to just being a flat line. Bigger, steeper. H and k we know are horizontal and vertical shifts, and I'll show you why that works. So if we do f of x equals the absolute value of x, and let's do plus 3. Let's make our chart. X, f of x. We plug in negative 2, negative 1, 0, 1, and 2. If we plug in negative 2 here, we get negative 2 plus 3. Let me write that out inside the absolute value. So negative 2 plus 3 is 1. And absolute value of 1 is 1. If we do negative 1, we get negative 1 plus 3 inside the absolute value. Negative 1 plus 3 is 2. And we know the absolute value of 2 is just 2. So 1 gets 2. Negative 1 gets 2. If we plug in 0, 0 right here, 0 plus 3 is 3. I just got my fingers. 0 plus 3 is 3. Absolute value of 3 is still 3. Bet you can see a pattern. If we plug in 1, 1 plus 3 is 4. Absolute value of 4 is 4. If we plug in 2, we get 5. And absolute value of 2 is 5. So if we were to graph this right now, negative 2 comma 1 would go here. Negative 1 comma 2 would go here. 0, 3 would go here. 1, 4, and 2, 5 would go here. And you'd think, oh man, we've got a straight line. Well, it turns out that this should be a V. The problem is that we didn't use enough points to figure out the whole V. We've just got the right half of the V. So we need to do some other points. So what if I did negative 3, negative 4, and negative 5? Let's plug those in. If I do negative 3 plus 3 is 0. Absolute value of 0 is 0. If I plug in negative 4 plus 3 is negative 1. Then I do the absolute value. Absolute value of negative 1 is positive 1. Here we go. So negative 5, if I plug it in, I get negative 5 plus 3 is negative 2. And then I do absolute value and get positive 2. So now let's plot these points. Negative 3 comma 0 is here. And negative 4 comma 1 is here. And look, now we're starting to go back up. Negative 5, 2 is here. And I bet if you did negative 6, you'd get positive 3. And so on and so forth. So there's our function. And look what happened. It moved. It's the same as our regular function, right? It's up 1 over 1, up 1 over 1, up 1 over 1. It's facing upwards, except it's moved over to the left 3. So this number right here, it's a positive 3. So whatever its sign is, we think of the opposite. It says plus 3, so we think minus 3. And minus 3 sends us to the left 3. If I were to write f of x equals absolute value of x minus 3, we think the minus 3, right? We change the sign in our heads to a positive 3. And positive 3 means 3 to the right. So then my graph would look like this. So in green, I have my graph f of x equals absolute value of x plus 3. And in brown, I have f of x equals x minus 3, absolute value of x minus 3. Same graph, except one's 3 to the left. The plus 3 sends it to the left. I know that's reverse, right? You'd think plus 3 is to the right, but it's the other way. It sends it to the left. And f of x equals absolute value of x minus 3 sends it to the right. That minus 3, even though you think minus, go to the left, it's the opposite here. You got to remember that. It sends it 3 to the right. So the number inside next to the x, added or subtracted, is going to be a horizontal shift. It's going to shift it left or right. If I wanted to shift it 4 to the left, I'd put a plus 4 here. If I wanted to shift it 10 to the right, then I'd put a minus 10 here. Okay, so now let's talk about our other variable in our standard form. We've already talked about a. We've already talked about h. Let's talk about k. K is really easy because h has a minus sign next to it. That's why we do the flip in our head, right? A negative number sends it to the right. A positive number sends it to the left. For k, it's just whatever it tells you. So if I have a plus 3, it's going to move it up 3. And if I have a minus 3, it's going to move it down 3. So let's show that. F of x equals absolute value of x. And then on the outside, because that's where k is, we're going to add 2. So as I said earlier, k, you just do what it says. So it's going to end up shifting it up 2. But let's show that. Let's plug in some points and make sure. Negative 2, negative 1, 0, 1, and 2. Okay. If I plug in negative 2, I get positive 2, right? Because it cleans it up. And then I add 2 more, and I get 4. Absolute value of negative 1 when I plug it in is 1. I add 2, and I get 3. Plug in 0. Absolute value of 0 is 0. Add 2, I get 2. Absolute value of 1 is 1. Add 2, I get 3. Absolute value of 2 is 2. I add 2, I get 4. So you can already see I have the turnaround in here. So I have enough numbers that I've chosen to get a V. 4, 3, 2, and then it starts shooting back up. So negative 2, comma 1, 2, 3, 4. Negative 1, comma 3. 0, comma 2. 1, comma 3. And 2, comma 4 makes my V. It's still up 1 over 1 because I didn't change the number in front of the x, right? It's still that up 1 over 1 slope on both sides, up 1 over 1, right? Both sides. But now it starts here. It's shifted up 2. So the plus 2 made it go up 2. If I did a minus 2, it would shift it down. So if I did this, f of x equals absolute value of x minus 2 on the outside, I'll show you what it looks like in brown. It would start here, because it's instead of 2 up, it starts 2 down. And because the slope is still 1 over 1, it has the same slope. It just starts a little bit lower. So this is kind of like our y-intercept from linear equations. Now if we put this all together, we change a bunch of stuff all at once. Let's leave a alone for now. And let's just change h and k for this video. So I'm going to give you x minus 3 plus 2. So I'm changing both of these. So remember, this is our horizontal shift. And for the horizontal shift, we do the opposite of what it says, left or right. So it says negative 3, so we're going to go 3 to the right. Plus 3 to the right. We do the opposite of what it says. For this guy, we just do what it says, and that's going to be 2, since it's our vertical shift, up. So if we make a quick sketch, we would imagine that our graph is going to look like this. Instead of starting at 0, it's going to start 3 to the right, 1, 2, 3, and 2 up. So it's going to start there. That's going to be where our vertex is. So if you wanted to, you could write the vertex as a point, 3, 2. And I got that information from this. Change this guy's sign, keep this guy's. So that's where our vertex is going to be. And then to do a quick sketch, it's going to be something like that, opening upward, because there's no number in front of here. It's just up 1 over 1. So that's absolute value in a nutshell, and the different numbers that you can plug into it to mess with it. The A value determines how steep it is and what direction it goes. A positive A means it opens upwards. Negative A means downwards. The bigger A is, the steeper it will be. H, if H is negative, and we plug it in, and we get something like this, right? So if I plug in a negative version of H, right? If I plug in a negative version of H, 2 negatives make a positive. So that's going to send it to the left because H was negative. Remember, we take the sign here and we change it. And if it's positive, or I'm sorry, negative, so we just plug it in like that, we get x minus h, and x minus h is going to send it to the right. We take the sign and change it. So this is our left and right shift. Whatever the sign says, you do the opposite. Positive means we go to the left, negative means go to the right. K, on the other hand, is very easy. It's our up and down vertical shift. Positive means up, negative means down. And using this, you can create any absolute value graph you want. You can start it wherever you want. You can have it open up downwards or open up upwards. You can change the steepness with A, and you can make any V you want with this. So that's absolute value in a nutshell. Next time I'll be going through how to do absolute value from the graph and come up with the equation, and the other way around.